In this video, we're going to look at a different topic called trig substitution, and this is where if we're given an expression such as the square root of 49 minus x squared, and we want to change this algebraic expression into a trig function, and we're going to do that by letting x equal 7 sine of theta. Okay, and that will be given to you. You're not going to have to determine what to let x equal. This will be given to you in the problem. They'll tell you what to let x be equal to. Now, this topic is something that you would see a little bit more in calculus. So for those of you that are going to take calculus 1, this is a topic that you will apply then. So for right now, I'm just going to go through just a few examples. And if you plan on taking calculus in the future, this is a topic that you will be using at that point. So this is pretty straightforward and easy. You're going to simply take wherever x is, we're going to substitute in the 7 sine of theta. So here we would have the square root of 49 minus x squared. So in place of our x, we're going to substitute in 7 sine of theta. And we have to keep in mind that all of this is still going to be squared. So make sure you put parentheses around not just the sign, but also the 7. So now we simply simplify this. So we would end up with the square root of 49 minus 7 squared, which is 49, and sine theta squared would be sine squared theta. Now at this point, because this is being subtracted, we cannot take the square root yet because of the subtraction sign. The only way that we can take the square root is if we have multiplication. For example, if we had the square root of 4 plus x squared, we cannot simplify that. This does not equal 2 plus x. Okay, this is completely wrong. The only time that we can take the square root of individual pieces if it happens to be multiplied, such as 4 times x squared, then we can simplify this to 2x. So over here we have the subtraction, so what we're going to do is we're going to actually take and factor out the 49. We have 49 in each piece, so if we factor out a 49, we'd be left with 1 minus sine squared theta. And once again, this looks like a Pythagorean identity, which is our sine squared plus cosine squared equals 1. So 1 minus sine squared is going to be equal to cosine squared. So all of that becomes cosine squared theta. Now what happens? We changed it from subtraction to simply multiplication, and now we can take the square root and make this 7 cosine of theta. And I know for right now you're thinking, well, this didn't do a whole lot, but we did eliminate the square root and we changed it from an algebraic expression here into more of a trigonomic expression. And this will be very helpful for some techniques that you will use in calculus. Now, over here at the side, I want to kind of look at this as an alternate way. This is probably the way that you want to do it, but another way that we could solve this problem, and this is kind of a way we can also check ourselves. If x is equal to 7 sine of theta, then that means if we move the 7 over, that means that the sine of theta must be equal to x divided by 7. And if we want to think of this in terms of our right triangle, okay, here's our angle theta, then sine of theta deals with opposite over hypotenuse, so that would be x, this would be 7, and I'm going to shorten this up. We would do the Pythagorean theorem, which in this case this is the hypotenuse, so this would turn out to be, the missing side would be 7 squared, which is 49, minus the other side, which is x squared. So now if we look at this, we have our right triangle, and the main goal here is we want to come up with something to represent the square root of 49 minus x squared. Well, notice that is the adjacent side that we just found. So if we look at this side, And then we have the opposite side, which is x, but we don't want to use this side because this contains a variable, and our goal up here is to eliminate this variable x squared. So we want to use the side that doesn't contain a variable, which in this case would be the hypotenuse. So if we look at the adjacent side and the hypotenuse, we are dealing with what trig function? Well, that would be the cosine. So that tells us that the cosine of our angle would be adjacent the square root of 49 minus x squared, all divided by 7. Now, remember, we're trying to solve for this square root of 49 minus x squared. Well, we have the square root of 49 minus x squared. All we have to do is eliminate the 7. So if we multiply both sides of the equation by 7, we would then end up with 7 cosine of theta equals the square root of 49 minus x squared. So that means here this 7 cosine theta is equal to this expression, which is exactly what we found over here. Okay, so keep in mind the easiest way probably for you is the method on the left, but if you like the right hand side, you can certainly use it as well. All right, let's look at another example. If we have the square root of x squared minus 4, and they tell us that x is equal to 2 secant theta. Once again, we want to use this trig substitution. So in place of x, we're going to plug in 2 secant theta. So that means we would have 2 secant theta. And again, this is the whole quantity squared minus 4. So be careful, when we square the whole quantity, we're going to get 4 secant squared theta minus 4. And once again, it's subtraction, so somehow we got to get this to be multiplication, and we're going to do that by factoring out the common factor of 4, which would be secant squared theta minus 1. And once again, we will notice we have this secant squared theta minus 1, which is a Pythagorean identity. Secant squared theta minus 1 is going to turn out to be equal to the tangent squared. So we would then have 4 tangent squared theta, and if we take the square root, we would end up with 2 times the tangent of theta. Okay, and you could check this again using the same process I did up here with the first example with using the right triangle, but in this case I'm not going to do that, but we could certainly draw a right triangle here if you wanted to kind of double check your answer. And for 2 secant theta, that means that secant theta would have to be equal to x over 2, and from here you could label your triangle to verify that we have 2 tangent theta. All right, I'm going to look at one more example, and this one's going to involve the square root of 16 plus x squared, and we're given that x is going to be equal to 4 tangent theta. So once again, that means in place of our x, we're going to end up with the square root of 16 plus 4 tangent theta quantity squared. So if we square this, we're going to get 16 plus 4 squared is 16. So then we get tangent squared theta. And once again, we can factor out the 16, which is going to leave us with 1 plus tangent squared theta. And once again, the tangent squared, or 1 plus tangent squared, is one of your Pythagorean identities, and 1 plus tangent squared is going to be equal to secant squared theta. and we still have the 16 out front. So now we're able to take the square root, and we would have 4 secant theta. Okay, so this is just a topic I want you to introduce you to a little bit and practice a few problems with using the trig substitution. And once again, you'll see a lot of this a little bit more in a calculus class.